Now we're going to look at normal distributions and how the graphing calculators can help us calculate those. So this is a lot less work than if I'm looking up the values from my Z chart for normal distributions. So the shortcut is to use the command normal CDF, and you're going to find that command in second bars. So it's also here in distribution, which means I'll have to hit second and bars in order to find it. And notice there is a PDF and a CDF. I want CDF. So the commands that it takes are four. It requires the lower bound, the upper bound, the mean, and the standard deviation. And so I've given you 3 sample problems. I would always have the students draw the normal distribution, label both the mean and standard deviation, and the x value that they're trying to find. So in this particular case, they were looking for the probability that an individual is less than 173, or we could also be looking for the probability that an individual was less than or equal to 173. Either of those are going to give me the exact same answer, since there's actually no probability for equal to 173, since this is continuous data. So my command, when I shade, I notice it's going all the way here to the left, which is technically negative infinity. So I'm going to use negative 1e to the 99, and it's a little weird. Your e is really the double E button, which is above the number 7. So you'll see it right here. It sits above the comma, and I'm going to need to hit second comma to get that E button. You'll see here in a second. My right bound is where I stopped shading, so 173, and then my mean and my standard deviation. So I'm choosing number 2, which is normal CDF, and I'm going to do negative infinity, so negative 1, second, comma, there's my E to the 99, so that's negative infinity, and then comma, and then my right bound, which was 173, comma, my mean, which was 152, comma, and my standard deviation, which was 12. And I get a probability of 0.9599. And that would be the same for both of these. Again, continuous data. It doesn't matter if I use the equal sign or just the inequality symbol. So now the second one, notice this time I'm looking at the probability of an individual being greater than 135, or it could even be greater than or equal to 135. So now my bounds have changed. This time, again, I've shaded now to the right, so my lower bound is the 135, my upper bound is positive infinity, and then my mean and standard deviation haven't changed. So I could either hit second enter and redo the numbers after normal CDF, or I could go back and start all over again. So I have 135, comma, 1 e to the 99, comma, 152, and 12. And I get a value of 9217. Again, for either answer. And then in the third example, this time I've done the probability that I'm between two values, those being 148 and 180. And again, it doesn't matter if I include equals. I could do a number of things. I could have an additional equal sign here and not here, or I could have an additional equal sign here and not here, or I could have both. So lots of options. These will confuse the students for a little while. But now I notice that my lower bound is 148, the upper bound is 180, mean and standard deviation are still the same. So back to second bars to get normal CDF, which is number 2. Lower bound is 148, upper bound is 180, my mean and standard deviation are still the same two values, and I get 0.6207. Keep in mind that I could change these to percentages. They do represent areas as well as probabilities, since the area total underneath my curve is 1.